Going on, ladies and gentlemen? Today we're moving on with lesson 8.4, inverse trig. So think last class 8.3 we talked about trig ratios. We used trig ratios to help us find the measure of side lengths. Today we're going to use inverse trig ratios to help us find the measure of angles. So it's very similar to 8.3. We're just basically in a way doing the opposite of 8.3. Okay, so a quick do now, quick refresh. Label the side lengths as opposite, adjacent, and hypotenuse, and use sine, cosine, or tangent to solve for the missing side lengths, x and y. So here is our angle. This is our theta, right? Which means that x is going to be opposite, y is going to be adjacent, and 9 is going to be our hypotenuse, all right? So if we're going to solve for x, that means we have opposite and hypotenuse. Remember, opposite and hypotenuse uses sine. So it's sine of theta, but our theta is 51. So sine 51 is equal to opposite over hypotenuse, which ends up being x over 9. Okay, x is on top, which means we multiply 9 to both sides. So x is going to equal 9 times sine 51. And once again, you need to use a calculator for that. You can't see me using the calculator, but I am using the calculator, and we end up getting an answer of 6. X equals, rounding to the nearest tenth, it ends up being 7.0. Okay, now if we're going to solve for y, now we have adjacent and hypotenuse. So instead of using sine, we're going to now use cosine. So we have cosine 51 is equal to y over 9. So again, y, the variable is on top, which means we would just multiply the 9 to both sides. So we end up with 9 times cosine 51. Again, use a calculator. You can't see me using it, but I am using a calculator, and we end up finding that y is equal to 5.7 after rounding to the nearest tenth. Okay, so these are regular trig ratios, and we see that they help us find the side lengths of triangles. Okay, so trig ratios help us find side lengths. Okay, the objective of today is to use trig ratios to find missing angles in right triangles, right? So 8.3, like I said, found missing side lengths. Now with inverse trig, we're finding missing angles. Okay, so once again, a refresh, theta is a symbol used to represent angles, similar to a variable such as x or y. Theta is used as a reference angle or the given angle. Okay, so now since in this lesson we're finding angles, theta will always be present. Theta is our variable. Okay, so just review sine, cosine, and tangent. So TOA, sine is sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. Okay, that's what we talked about in 8.3 already. All right, just like how we can use sine, cosine, and tangent to find missing side lengths like we did in 8.3, we can also use it to find missing angles, and which is obviously mind-blowing because math is incredible and amazing. Okay, so inverse, right? This lesson is called inverse trig. In math, the inverse means the opposite. So think about any type of equation that we've ever worked on, right? I'll give you the most basic example, right? X minus 2 equals 5. Okay, whenever we're solving for x, to get rid of minus 2, we always do the opposite, which is plus 2. And usually I just say opposite. Technically, if I wanted to be super mathematically correct, I should say the inverse, right? So inverse just means opposite, okay? So the inverse of minus 2 is to add 2, and that's why we do those things to both sides, and we find out this equation is x is equal to 7, right? Similar to this, the opposite of sine, cosine, and tangent is inverse sine, inverse cosine, and inverse tangent. And remember, I talked about it last class that sine, cosine, and tangent is super, super complex. That's why you have to use the calculator, right? So whenever you see inverse, all inverse is just making sure that you see this -1. This -1 means it's the inverse, right? So the opposite of cosine is inverse cosine. The opposite of sine is inverse sine, and the opposite of tangent is inverse tangent. Okay, so that's all that inverse means. Okay, it's the opposite. Okay, we still set up the problem the exact same way. Label your side lengths as opposite, adjacent, or hypotenuse. Decide which ratio that you have to use, sine, cosine, or tangent, and then set up the equation. And now we're just going to use inverse trig ratios to solve for the angle rather than regular trig ratios. Okay, so using inverse trig on the calculators. This slide is my normal set of PowerPoint slides that I use. And if you're in class, I usually have a class set of calculators. However, with this crazy year, right, I'm not going to be handing out calculators to avoid unnecessary touching and passing of germs and whatnot. But these are the calculators that I have in class. To use to find inverse, you hit the second button and then you hit sine, cosine, or tangent. If we go back in and look at the Google calculator that I've been telling you how to use, if we go in here to find the inverse, right, sine, cosine, and tangent are here. If we want to use inverse, we hit the INV button over here. INV means inverse, and you see that sine, cosine, and tangent now changed to sine -1, cosine -1, tangent -1, which is the symbol for inverse, right? So that's how you're going to use inverse sine on the Google calculator there. Okay, so let's just go for some examples. Label the side lengths. Which ratio are you going to use and find the measure of angle A? So in angle A, we see we have theta. That's the angle that we're looking for, right? So opposite of theta is 30, so that's opposite. We see that 20 is our adjacent side. Okay, we have opposite and adjacent, which means we're going to use tangent. So we set it up. Our equation is tangent theta is equal to opposite, which is 30, over adjacent, which is 20. Okay, so now we have to solve for theta. A tangent is technically connected to theta. So to get rid of tangent and just find theta, we are going to do the inverse. So theta is going to equal inverse tangent of 30 divided by 20. Okay, and I'm going to do that on my end on my regular calculator, and then I'll show you how to do it on the Google calculator. So I type in remember, if I'm using a regular calculator, I'm hitting the second button, then tangent, and it shows up as tan -1. And then I'm just putting 30 over 20. Remember, 30 over 20 is a fraction, which means it's actually 30 divided by 20. And I close the parentheses and I hit equals. And then I find out that theta is equal to 56.3. So let's see if we can get that same answer by using the Google calculator. So let's take a look. We go in, right? I wish I wouldn't have erased that equation, but I think I can remember it. I have it still on my calculator. So we're going to hit inverse tangent of 30 divided by 20. We close the parentheses and we see, look at that. We got something different, right? So that's why it's important to go through and see how we can find out what went wrong here. So what I'm thinking is that we can't do 30 divided by 20 in the parentheses. We might have to do 30 divided by 20 by itself. Let's double check. I'm doing a lot of work that I should have done already previously to making this video, but we get 1.5. So let's see if we can do it differently if we do inverse tangent of 1.5. 0.98. Damn it. Okay, I found out what happened, right? Up here in the corner, right? Rad stands for radians, degree, DEG stands for degrees. Make sure your calculator is set up into degrees because we're finding the degrees, right? We're finding angle measures. So that's what went wrong. Now you see that if we did inverse tangent, we still get 56.3. So now I also want to double check to see if I can do inverse tangent of what we originally had, 30 divided by 20. Now that I know that I have it set to the proper thing, if I put that in, nice. Okay, so that's what happened. Make sure if you're using the Google calculator, you're using the degrees and not the radians, okay? I'm glad that we went through that. Awesome. So we go through, we do another example, right? A is theta, so that means 15 is opposite. That means 11 is adjacent. So once again, we're going to use tangent. We set it up, tangent theta. Theta is equal to opposite, which is 15, over adjacent, which is 11. Okay, so which means we're going to find that theta is equal to inverse tan of 15 divided by 11. And again, you can go in and check that into the calculator. So let's take a look. We do clear inverse tangent of, what was the ratio? Inverse tangent of 15 over 11, or inverse tangent of 15 divided by 11. we close the parentheses, and we get that it's 53.7, right? So the answer of this angle is 53.7 degrees. Okay, that's how you use the calculator, right? From these examples on, I'm just going to use my calculator here. I'm not going to keep going back and forth from the Google calculator. So once again, theta here, this is opposite. This is now hypotenuse, which means we have opposite and hypotenuse. We're going to use sine now. So we have sine theta equals opposite, which is 14, over hypotenuse, which is 26. So that means theta is equal to inverse sine of 14 divided by 26. So I plug that into the calculator. Inverse sine of 14 divided by 26. And I see that theta ends up equaling, theta equals 32.6 after rounding. And again, I know you can't see me on the calculator, but I am using it. You need to use the calculator, right? So theta over here now, next one, we see that 10 is adjacent, and we see that 16 is hypotenuse. So now adjacent and hypotenuse, we're going to use cosine. So our equation here is cosine theta equals adjacent, which is 10, over hypotenuse, which is 16. So to find theta, we're going to equal inverse cosine of 10 over 16. We plug that into the calculator now. Inverse cosine of 10 divided by 16. And we find out that theta is equal to 51.3 degrees. Okay, and our last example, once again, we see that we have theta, which means that this is opposite. This here is adjacent, which means we're going to use tangent again. So tangent theta is equal to opposite, which is 8, over adjacent, which is 5. And to find theta, we use inverse tangent of 8 divided by 5. We plug that into the calculator. Inverse tan 8 divided by 5 equals 57.99, which means that it rounds theta to 58.0. Okay, and that's it for this lesson. Okay, once again, just like always, make sure you bring lots of questions to class. Okay, have a great day. Go Mustangs.